The laptop greatest branding scam, or how I like to call it, LGBS, is actually something most of the people don't even think about. And that is exactly the point. You wake up, you scroll through tech reviews, you see ads, you see YouTubers unboxing the newest $2,500 laptop. It looks incredible, it feels premium, the cooling, the design, the technology. And you think, yeah, I need that. But here's what nobody actually tells you. A wise man once said, you don't make money on the rich, but on the poor. Well, the laptop industry never got that memo, because they're doing the exact opposite, and they're making a ton of money doing that. And now the question is, are you one of the people they are making a lot of money off? Stick around, we are going to expose how the greatest laptop brands pulled off one of the most brilliant and most shameful scams in the tech history. And by the end of this video, you're either going to be angry or sorry that you spent that much on a laptop. As you've probably seen on the thumbnail, the LGBS is a liquid metal. For those who don't know what liquid metal is, it's an alloy made of gallium that helps transfer heat from your CPU and GPU to your cooling system, radiator plus fans. So now, why are the BTC, big tech companies, using liquid metal instead of thermal paste? The excuse they give us for that is that it has a thermal conductivity rating from approximately 70 watts per meter Kelvin. That's the fancy way of saying it transfers heat really well. Compare that to traditional thermal paste. For example, your standard high-end thermal paste goes from 4 to 8 watts per meter Kelvin, sometimes up to 15 if you're using something nice like Thermal Grizzly Duranote or the Arctic MX6. So on paper, liquid metal is roughly 10 times more conductive than thermal paste. Sounds incredible, right? Like, why wouldn't every laptop company use that instead? Well, that's exactly what the marketing team wants you to think. Because here's the thing they don't tell you. You don't need it. Your laptop doesn't need it, and frankly, your laptop is better off without it. The better the thermal interface material, that's the paste or liquid metal between the chip and heatsink, the more efficiently that heat moves on. Less heat buildup on the chip means better performance, longer lifespan, and less thermal throttling. That is not the entire story. A cooling system is not only made of thermal paste or liquid metal, but of several other parts, such as the radiator and the fans. Meaning, if the radiator or the fans are a bottleneck to the thermal conductor, the cooling will be the same with a cheaper, less risky compound. If you didn't get what I meant, basically the performance of your laptop's cooling doesn't depend that much on the thermal interface material. Real differences come only from a bigger radiator and faster fans. Now let's talk about actual power consumption, because this is where the whole liquid metal thing falls apart. Most modern laptops, and I mean the vast majority of them, have a CPU that draws between 15 to 50 watts under full load. Your GPU another 25 to 150 watts depending on whether it is integrated graphics or discrete graphics. So combined, you're looking at somewhere between 50 and 300 watts of heat that needs to be dissipated at max capacity. But don't forget that this is not per chip. Usually per chip it's half that, especially on CPUs, as even powerful gaming laptops don't pull more than 50 to 70 watts. That's the absolute maximum for even the most powerful gaming laptop. Besides that, the power plant responsible for boosting the laptop to such high wattages have time limits, usually up to 2 minutes. Now here's the kicker. Thermal paste is already more than capable of handling this. Think about it logically. Thermal paste has been used in computers for decades. It works, it's reliable, and it's designed to move heat away from a chip. The real difference between your average thermal paste and premium thermal paste is around 2 to 3 degrees Celsius under load, and the premium one lasts a few more months before needing to be repasted. That's it. So when you're generating 200 watts of heat and your thermal paste can already move that heat efficiently, what does liquid metal do? It moves it slightly more efficiently. We're talking about a 5 to 10 degrees Celsius difference in the best case scenario, usually between 2 and 4 degrees. Let me show you some real data here. This is data from a tech reviewer who tested several thermal pastes and one liquid metal. You see the CPU temps? Almost identical. The difference is so negligible that it's really not worth mentioning. Both are well within safe operating temperatures under full load. And here's the thing that really gets me. Neither of them is even approaching a thermal limit that will cause problems. Modern CPUs are designed to handle sustained temperatures up to 95 to 100 degrees Celsius. Well-maintained laptops on thermal paste never go above 80 to 90 degrees Celsius under stress. So you're already living at 10 degrees safety margin. Liquid metal might shave off another 2 to 5 degrees Celsius. That leaves you with a 15 degrees Celsius safety margin instead of 10. This solves absolutely nothing. Now you might think, we talk about which is worse, but is there really a point? People who love performance will appreciate a 5-degree difference, even if they have to pay $10 more. Well, here's the plot twist. Those $10 more aren't the only money you'll have to pay for that performance. Liquid metal is electrically conductive. Thermal paste is non-conductive by design. That's the point. You want it to move heat, not electricity. Liquid metal, it conducts electricity, and when it spreads beyond where it's supposed to stay, which it does, it can bridge electrical connection on your motherboard. Capacitors, resistors, voltage regulators, all isolated for a reason. Introduce a conductive liquid between them and you create short circuits. Dead CPU, fried motherboard, device bricked. If we used liquid metal on PCs, the worst case scenario will be motherboard and CPU dying. But in a laptop, if something dies, basically the whole device is bricked. This happens constantly, and when it does, manufacturers say user-induced damage, not covered. It's their liquid metal, their design, but somehow it's your fault. Gallium, the main component in liquid metal, attacks aluminum and copper. Your heat spreader, basically your radiator by the way, is aluminum. Your motherboard is copper. Over time, liquid metal literally eats into the metal. It corrodes and the surface degrades. Here's the irony. Liquid metal becomes less effective as it corrodes the surfaces it's supposed to conduct heat through. Thermal conductivity stays high, but contact resistance increases. Overall heat transfers gets worse. A 5-year-old thermal paste laptop still perfect. A 3-year-old liquid metal laptop already showing significant corrosion. Manufacturers know this. It's basic chemistry. They don't care because the device is already out of warranty by the time it matters. This is the LGBS in one sentence. They put a conductive liquid inside, it spreads predictably, it causes a failure, they call it accidental damage and deny the warranty, or the warranty was already expired. Now, if you think about it, every nice laptop comes with liquid metal. So what should you do? How can you avoid the LGBS? Buy that laptop that you want, get it to a specialized repair shop and change that god-awful metal with some PTM 7950 or a nice thermal paste like the Arctic MX6. I personally swapped the liquid metal with some MX4 for 2 Rockstrix G16 last year. You could also get a second-hand laptop or a refurbished one, as changing liquid metal will void your warranty anyways, because they won't be able to make easy money out of you. But be careful not to get a laptop older than 1 or 2 years, so the radiator doesn't corrode too much. Doing all of this will secure your capable device, and life-wise it will last way more like laptops used to. This was my take on liquid metal, as an experienced PC nerd. Be smart and do your choices smartly. Be like